Hi everyone. In today's session, we'll be covering a few basic yet very important topics in web security, which are cross-site scripting, CSRF, and SSRF. Uh, let's get started with cross-site scripting. The basic idea behind cross-site scripting or XSS is that an attacker manages to insert their own malicious, and arbitrary JavaScript code into an otherwise harmless website. So the key idea is to get a victim's browser to execute this bit of arbitrary and malicious JavaScript code whenever the victim visits the website and loads the web page. So, and XSS also allows attackers to circumvent the same origin policy, which restricts, the origin of scripts to self, and it doesn't allow, scripts that are from external sources. So, a very simple test or proof of concept for XSS involves using the script tag. So now I'll tell you guys what the script tag means in HTML. Whenever you visit a website and you load a web page, right, what happens is that the browser passes through the entire HTML document for that web page, and then it renders the HTML accordingly. And as soon as it encounters a script tag, which is a tag in HTML, whatever comes after the script tag and before the closing of the script tag is considered as JavaScript by the browser. And this bit of JavaScript then gets executed as soon as the web page is loaded by the victim's browser. And that's what happens in case of XSS. An attacker manages to insert their own arbitrary JavaScript into a website through some means. And for a successful XSS attack, three important conditions need to be satisfied. That is, the website must take in some kind of user input from users. Now, user input can be anything. It can be a form that is present on the web page explicitly, or it can be even be a parameter that is part of the URL. So as long as anything that's can be controlled by the users, it is considered as user input. And yeah, so as long as there's any input that can be controlled by users and is part of the request, then it is considered user input by the server. So yeah, that was the first condition. And the second condition is that the server must not perform any kind of validation or sanitization on the entered input. Then if that were the case, then our XSS payload wouldn't work in its intended way. So this would be the second condition. And the third condition would be that the uh, whatever input that we've entered into the into the website through XSS, it must be, you know, returned exactly as it is in the response that is sent by the server. So whatever input we sent into the server must be returned as it is, and it need not get rendered on the web page exactly, but what is required is that whatever input that we enter is returned in the response as it is. If these three conditions are satisfied, then an XSS attack is possible. So let's take a look at what this means through this, dummy application that I'll be hosting in my own machine through. This will be a Flask application. So and this application is vulnerable to a good number of, attacks, and XSS is one of them. So let's try to see what it looks like. And yeah, alert is nothing but a JavaScript function that, pops up a message. And I know this is not that harmless, but if you're able to do this, then it means that you can execute any arbitrary JavaScript of your choice. So let's try that out on this server. Yeah, I've hosted a server here. Let's try and run it. So yeah, this is a dummy web application, which is hosted locally, and it is a Flask server. So, I mean, what it does is it just takes in whatever input you enter in, and it, displays it on the web page as it is. So, let's take a look at what's going on behind the scenes by viewing the source. So, this is the HTML document of the web page, and yeah, it just takes in and displays whatever as it is. So, yeah, it satisfies the first and second criteria. Now let's see if it, first and third criteria, sorry, let's see if it does perform any encoding or validation on the entered input. If that is the case, then yeah, XSS would not be possible. But if it doesn't, then yeah, it would be vulnerable to XSS. Now, yeah, let's just try entering in a script like we saw earlier. So instead of any string, let's try entering in script and then alert, and then we close the script tag here. So yeah, let's try and enter it and see what happens. So there we go. We have proved that this application is vulnerable to XSS as we were able to inject this bit of payload into it and get we got the browser to execute this bit of JavaScript right here. So and yeah, let's take a look at what happened so that we get a clearer picture. So yeah, instead of the original string, we entered this thing in, and then yeah, it got stored in the HTML page as a script. So as the browser passes through each of these lines, it encounters the script tag, and then yeah, whatever comes after this is considered as JavaScript and gets executed. So that's basically what XSS is all about. Somehow, if you manage to inject your own JavaScript into a website through some means, then yeah, that would be XSS. And yeah, this example was very harmless. All you did was pop up an alert, and that is pretty harmless, right? So, but then XSS can be, leveraged to perform any kind of arbitrary action, such as what I'll be showing in the next few slides. So, and yeah, XSS can do much more than just print an alert pop-up. It can cause any arbitrary JavaScript to get executed, which can perform all sorts of malicious actions, such as, and one of them is stealing credentials from a login page. So consider a login page to a website, right? Uh, there are users visit this web page and then click on a submit button to enter in the username and password and get authenticated to a website. Imagine, right? So here, if we somehow manage to inject this bit of JavaScript right here into this website, then we can possibly steal people's credentials when they log into this website. And that is done by adding this event listener, right? And that is part of this form, which essentially collects the username and password as soon as they are submitted. And that is accessed by document get element by ID, and then use it stores the username and the password separately. And then what it does is it calls fetch, which is essentially a JavaScript function which is used to handle asynchronous requests to any URL from a server. So what it does is whenever a user submits their username and password, it gets stored in these variables and then it is passed on to this URL. And this is nothing but a server that is controlled by the attacker. So it sends out a request to this URL with the username and password of a user of a victim, and then essentially means that the attacker gains access to these usernames and passwords. And obviously, this kind of attack isn't possible in most sites because they would have much more secure, methods to authenticate users than and they would simply not simply username and password won't be enough, right? There would be much more secure methods in place anyway. So this and yeah, they would not also allow XSS vulnerabilities to just be hanging around in such a age that requires a high level of security. But yeah, this is one way by which XSS can be used to steal credentials. And yeah, so yeah, the second, action somebody could perform is to hijack a session by accessing the cookies. In this example, what they're doing is they're just accessing the cookie of somebody who's logged in to a website through document.cookie, which gives JavaScript access to the cookies that are part of a website. And then it's just sending another request to this attacker control website with this parameter. So if somebody who's logged into a website, right, a cookie is created and it essentially helps them to manage their sessions, right? And then if an attacker could, grab hold of these cookies, then they could instead log in with the cookies. And yeah, this would work only if the website is relying only on cookies for session authentication, user authentication. And then another example would be to compromise a downloads page to install malware. So yeah, here what's happening is that grabbing every download link using this ID class name, and then And then the attack is essentially setting, all these download links to reference to this URL instead of the actual download link, so that whenever a link is clicked on, this request is sent to this, website, and then this program gets downloaded and all that. So yeah, XSS can perform much more than simply, popping up an alert, right? So, and yeah, very important topic in,
Siddharth,
yeah,
like, will you be recording the session?
yeah, I'm recording it currently. Yeah, I'll be uploading them later on. Okay, so in XSS, a very important topic is what's called as context. So, context essentially refers to the location in which the payload is written onto within an HTML document, right? And what payload to use depends on what context the payload is being written onto. So, in different cases, we have different contexts and different types of payloads accordingly. So, in case the context is between HTML tags, so let's say you have these multiple HTML tags in a website, right? And then in between them is where your input is going. If that's the case, then your context is between HTML tags. In that case, the following payload would work. So you can just insert a separate script with an alert within it, and then that would execute accordingly. You can have what are called event handlers also, which are events that get as soon as an event occurs, these things get triggered. So when an error is, occurring, this gets executed. Similarly, when something is loaded, this gets executed. All of this is possible because of event handlers in HTML. So so when the context is between HTML tags, this would what the payload would look like. And in the other case, if the context is into an HTML tag, so in the previous case, it was between HTML tags. Now, in this case, it's going into the tag. So what it means is you have a tag, and whatever data that you're entering it is going into it. And in this case, you would want to break out of the tag and then create your own new tag with the malicious payload enclosed within it, right? And also, if it's an href attribute in an anchor, which is used to, include URLs, then you can do this, which is a method that's possible only for href in JavaScript. So that is also an option. And the third case is if it's inline JavaScript. So now this is not going into HTML. Instead, it's going into JavaScript, right? So in this case, you would first want to close that that script in which your payload is going into, and then create your own new tag with the payload in it, right? So what happens here is before this was JavaScript, or everything that came before this is JavaScript, like legit JavaScript that is, intended to be part of the website. And then here you're closing it and then beginning your own new tag with the, payload in it. And then if it's going into a string in JavaScript, you can attempt to break out of the string and then alert and then call your JavaScript functions that you would like in order to execute your payload. In some cases, what JavaScript would do is it would try to prepend backslash into in order to ensure that certain characters are escaped. In that case, you would try prepending your own payload with your own separate escape character, so that the original backslash is escaped, and then whatever comes after that gets executed normally. So that's why in this example you have this backslash as part of the payload. So yeah, whenever you carry out an XSS attack, right, you would not exactly know which payload to use. In that case, you would want to try out different payloads, right? If you're using burp suite intruder, for example, in that case, these websites have very comprehensive lists of payloads that you can use for trying out different parameters to see what is vulnerable and what is not. So if you visit these links, you have these lists of payloads that can be used. And XSS has three different types primarily. They're called reflected, stored, and DOM based. Now, reflected and stored are very different from each other. But on the other hand, DOM based has overlap with both reflected and stored. So you have both reflected DOM based and stored DOM based, right? And in case of reflected XSS, what happens is whatever payload that you enter into the website, right? It doesn't get stored in it. It gets sent along with the request to the server, and the server sends the response accordingly with the payload in it, so that whatever malicious JavaScript that you've included in it gets executed along with it. Nothing gets stored in the server. It's just part of the request and the response. That's it. So in case of requested XSS, the key idea is to inject a script into a website so that it gets executed and the output gets returned all within the victim's browser. So what essentially happens in reflected XSS is the attacker has to, make sort of create their own malicious URL with has the payload in it. So this could be in case the payload can be the vulnerable parameter is some sort of URL query parameter. So that's part of the URL, right? If that's the case, then they could set the parameter equal to the malicious payload, and then they could make a victim click on this URL, vulnerable URL. And then when that happens, the malicious request is sent from the victim's browser to the server, and then the server responds accordingly with the JavaScript in it, the malicious JavaScript in it. So let's look at an example for this. Let's say there are two websites, a legitimate website with this URL and a website controlled by the attacker with this URL. Now, say the attacker would intend to steal cookies of legitimate visitors to the vulnerable website. Now, why an attacker would do this in case there's a website in which many users are already authenticated, and in case the attacker has access to the cookies, they could simply try, logging in with this particular cookie. And also, like I said previously, this would work only if the website relies solely on cookies to authenticate its users. Then, in this case, the relevant XSS payload must be something like fetch with the attacker's website and document.cookie. So what happens is it's essentially setting cookie parameter to the document.cookie attribute from which it takes from the user's session, and then it just appends it to this URL and sends it to this website, the attacker's website. So once this happens, the attacker's website gets access to this cookie, and whatever action that was intended can be performed. And yeah, this would be enclosed within a script tag since it's a malicious JavaScript. And then, yeah, the actual attack would consist of the following steps. The attacker would first confirm the presence of an XSS vulnerability in the site by testing out different input values. And then it is found out that this particular parameter is vulnerable to XSS. Then what happens is the attacker creates a malicious URL for the legit website with the payload in it as one of the input parameters. Now, this is the URL that the attacker would make the victim click on. So in this case, this is the legit URL to the legit site, but instead of query, which is the vulnerable parameter, instead of an actual query, it contains the, malicious payload in it with the script tag and everything. So now this URL is problematic. Anybody who clicks on it, their session will get stolen essentially. And yeah, this URL is then delivered to a victim by some means. So unsuspectingly, the victim would then click on this URL and then this would get executed, right? So that's what happens in this case. In case of reflected XSS, you would require a user to interact along with, the attacker. So for the attack to be possible. So this is very different from stored XSS, which we'll be seeing in a bit. And yes, when the victim clicks on the link, the victim's browser sends a request to the server with the payload in it, right? And the server responds, and then the HTML document is loaded and the malicious script gets executed. So in reflected XSS, the attack does not persist in the website. It is reflected immediately to the victim, and then that's why it's called reflected XSS. So we have a demo on Portsfigure that we'll be looking at. I'll give you guys the link. So yeah, this is the most basic lab in this series, and that's what we'll be doing. And I'll send the link in both the Meet chat and WhatsApp. I'll give you guys a few minutes to try it out on your own. I'll give you guys a few minutes to try it out on your own and then discuss it. I've sent it in WhatsApp, so you would have received it by now. I'll be doing the lab on my own anyway, for you guys to follow along. In case you would like to do that, then yeah, feel free to do that. But then you're also free to try the lab out on your own. So yeah, right here we have this website which is supposed to be vulnerable to reflected XSS. And like the lab says, all we're supposed to do is call the alert function. Now, yeah, in every one of these examples, we'll just be doing alert for XSS, right? So as long as we're able to do that, then that means that the application is vulnerable to XSS. So let's try entering in a random string so that we'll see what's happening. And yeah, this is what gets displayed. And let's take a look at the source in order to figure out where it's gone into. Okay, so right here it's going between an HTML tag with this H1 ID. So this would be the first context, right? We would try injecting in a separate script tag with the payload in it. So yeah, let's just try out the most simple payload among. So there we go. We have solved the lab, and this was a very simple lab. It was the most basic lab in the entire series. All we had to do was insert our own script with the alert in it. And in case you have any doubts, you may ask them. We'll also.
Could you like tell the differences in like the different types of accesses once more? I couldn't follow it properly.
Okay, I've only covered reflected right now. I'll be discussing stored and DOM-based after this, but reflected XSS is the kind of XSS in which uh, the payload gets sent to the server, and then the according response is returned immediately. So all of this happens only once, right? So what happens is the attacker first identifies the vulnerable, input parameter, and then they would try out different XSS payloads in it. And then once that is over, he or she would, you know, set one of the vulnerable parameters equal to the relevant payload. So in the example that I told you guys about in the website, the query parameter was what was vulnerable, right? So the attacker would then set query equal to whatever payload that they would like to insert into the website, and then all of this is part of the URL. So if you look at the URL for the vulnerable website in the example that I discussed, it would be vulnerable.com, and then the rest would be it would be followed by the parameters, right? So the first parameter would be query, and then whatever you're setting query to, that would be the server would think that you're searching for it, but then instead, if you put the payload instead of a legit query in it, then the server has no way of finding out whether it's malicious or not, right? And then what happens is the attacker just forces a victim to click on the link, and then the request with the malicious payload in the query parameter is sent to the server, and the server responds accordingly. And all of this happens within the victim's browser. It doesn't get the payload doesn't get stored anywhere, as we would see in the next case of XSS, which is stored XSS. So I hope this cleared your doubt, and we'll be moving on.
Yeah, yeah.
Yeah, sure. We'll be moving on. And then yeah, so the next type of XSS is stored XSS. It is also known as persistent XSS. In this case, the attacker's payload gets permanently stored in the target server. So this is very dangerous because the payload, since it gets stored in the server, right, it gets executed every time the website is visited by anyone. So anyone who visits a website loads the malicious payload that is part of the server's database or whatever now. And then once that happens, the malicious JavaScript gets executed in everybody's website. So this type of attack is typically possible in websites that allow public sharing of content like message forums, blogs, comment sections, review pages, and other social media platforms in general. So for example, right, in a comment section underneath a video, which no filtering is done on any comment inserted by users, right? An attacker can simply inject a script as a comment, like script and then payload followed by ending of script tag. I just wrote script here, but then yeah, he would be injecting a payload as part of as a single comment, and then what happens is the comment gets stored in the website's database, and then database or whatever, like wherever they store comments, this payload gets stored in it alongside the rest of the comments, and then when any user visits the comment section underneath the video, right, all these comments get displayed, right? Along with that, even the malicious comment which contains the payload in it gets displayed, and then whatever script that is part of the payload gets executed along with it. So unlike a reflected attack, where the script is activated only when the relevant link is clicked on with the payload in it, a stored attack requires that the victim visit the web page, and that's all that's needed for a stored XSS attack. All you need to do is, I mean, all the attacker needs to do is inject the payload once into the website, and then it just gets stored there permanently. Whoever visits the website gets infected by this attack. So yeah, they are probably the most dangerous of XSS attacks since they are, very, extensive, and the because of the sheer number of people who get impacted by these. It's not just limited to one victim, right? A lot of people, like whoever visits the website gets affected basically. And we have another demo for we have a demo for stored XSS. So in this lab, I'll be sharing the link with you again. Once again, for those of you guys who already attended the offline session, this is nothing more than a recap for you guys. But then, yeah, you can you're free to follow along. You're also free to attend the lab on your own. So yeah, this looks like a blog, and uh, underneath the blog we have a comment section, right? So let's see if this comment box is vulnerable. I mean, obviously it is, but like, let's try it out ourselves. Let's first, try out a normal comment that isn't harmless. So yeah, we were now able to, write a comment, and then we can see that our comment is now, part of the underneath comment section underneath the block. So let's try inserting a malicious payload instead of a legit comment, right? So for that, script and then alert. So like I said, I'll be using alert for all these demos since that's more than necessary to, prove that XSS is present in this website. So now the comment is now part of the website. Let's reload it. And yeah, once we do that, the alert gets executed and then the pop-up appears. So yeah, it won't, get displayed on the page because it's considered a script, right? It's not HTML anymore. It's just an HTML tag with a script within it. So it won't get displayed, but yeah, we were able to execute our own JavaScript in this website. So that was stored XSS, and yeah, like you guys just saw now, whatever enter into these kind of websites, they get stored in some sort of database, and then if you insert a malicious payload in it, and then it would then get executed in everybody's browser, everyone who visits the website, that is. Hope there are no doubts. I'm moving on. So the third type of XSS is called DOM-based XSS. So first of all, the DOM, or the document object model, is essentially a browser's representation of a web page's structure and its elements. You may think of it as a sort of like a tree-like structure with nodes representing each and every element of the website. So this, provides developers with an interface to dynamically modify the, content and the style of the web page and add or remove elements, all using JavaScript. So as long as a website is using, using DOM elements to dynamically modify the structure and content of the web page, and then if it's vulnerable to XSS, then through these elements specifically, then that would be a case of DOM-based XSS. So they usually arise when DOM-based XSS vulnerabilities usually arise when, JavaScript takes data from an attacker controllable source. So I'll discuss what source and sink means in the next few slides. But basically, as long as, JavaScript has control of all the data that any user would send into a website, and then if it's the same, DOM elements that are what control content that gets displayed on the website, then it may be possible that such a website is vulnerable to XSS, provided the other conditions are satisfied. That is, no validation or sanitization is carried out on the input, and there's no encoding on the output. So first, let's look at what source means in the context of DOM-based XSS. So sources are essentially points in the DOM from where user input enters the application. So in order to deliver a DOM-based attack, you need to place your payload or data into what's called a source, and this is where the application receives whatever input users are entering into it. And from the source, the input is then propagated to the sink, and the sink is where the actual payload gets, rendered on the page, and that's where the script gets executed. So an example for a source would be the URL, and this can be and all the parameters that are part of the URL can be accessed through the window.location object, which is one of the elements in the DOM. Window refers to the current window, and then location refers to whatever that's there in the URL. So you can access parameters from the window dot location through parameters from the URL through this window dot location object. So this was source, and then sink. Sinks are points in the DOM from where the input gets processed or executed. So whatever data that is contained in the source is directly passed to the sink, and then when it's carried out without any proper sanitization, then there's scope for an XSS vulnerability. And then we have these functions in JavaScript called eval and document.write. Eval is used to execute, whatever you enter into it, typically, JavaScript or whatever. There's a JavaScript function. You would execute something inside it using eval. And then document.write is used to, write anything that you include within it onto the web page. And then inner HTML is an attribute of every element in a web page. You can set the inner HTML equal to something, then that would set, render whatever you set the inner HTML to on the web page. You're essentially setting whatever HTML that is part of that particular element to your input, right? And then that's how inner HTML works. And yeah, all of these are vulnerable because they don't perform any sort of encoding when they, directly include data on a web page. So let's look at a demo for DOM based as well. I'll be sending the link in WhatsApp as well, just a second. Pay attention. It would be good to pay attention to what context the input is going into. So that would help you decide what kind of payload to use and what characters to use when entering in your payload. So a good way to do that would be to take a look at the source and see where the uh, whatever input that you're entering in is going, and then that would give you clues as to what kind of characters you might want to use. So like I said, like we always do, let's begin with by entering in a random string. So, okay, we actually did get a search result, but anyway, let's look at the source for this. So this was nothing but the heading above it, but then here's where the actual manipulation of the input happens. So let's take a close look at this bit of JavaScript right here, shall we? In this, right, we have this function called track search, and then it does this. I'll get back to it in a bit. First of all, we have set the parameter called search to whatever value that we've entered into right here, as we can see over here. And then that goes into query through this basically. So if you look at this line right here, you can see that query takes on the value of whatever parameter that is contained in this particular search, right? So, and that is accessed through window.location. So like I said, window.location refers to the URL, right? And then it has a parameter called search, and then it's obtaining it through get, and then essentially this gives it access to this particular string that we've entered into. That is sent into query, and then if query, then it performs track search on query. So now let's look at what track search does. You have query equal to random in this case. Now it carries out this, executes this function with query as one of the arguments, and then query is random, right? So it executes document.write basically. So here, the source would be window.location and the sink would be document.write. We're writing, we're dynamically writing data onto the web page through document.write. So because this is being carried out, this is an example of DOM-based XSS. So let's look at what's going on here. It's beginning an image tag and then it's setting the source to this URL, right? And then it is also appending the query value to this. It is setting the query to search terms equal to this. So now if you look at this source, whatever is contained in source, right? It is enclosed in a string. It is enclosed in double quotes, right? So this whole thing is double quotes. Now we would like to break out of this and then so that we can begin our own new tag. So first of all, we would need to use a double quote so that we break out of the string first. And then we would need to break out of the image tag separately using an angled bracket. And then we're free to begin our own new tag, right? And then if that would be a script tag with a malicious bit of JavaScript in it, then that would get executed when the web page is visited after that.
Could you tell what document.write does here?
Yeah, document.write essentially writes, data onto the web page. Basically, it simply displays it on the web page along with HTML, along with the rest of the HTML document. So essentially, it is trying to access this image with query in it. So obviously, if this image doesn't exist, there would be no image at all. But then it would write this bit of HTML onto the document. That's all what document.write does. So whatever argument that you give into document.write is HTML, right? Does that clear your doubt or?
Uh, so like, does that add that line into the HTML part of the website
Yeah,
and then that
exactly.
gets run?
Yeah, exactly. It
Okay, okay.
it gets
Yeah,
dynamically
understood.
added to the web page. Yeah, it's part of the HTML, rest of the HTML of the web page. So yeah. So now let's try inserting our own payload now. So like I said, we first would require to break out of the string, and then we would want to break out of the image tag, and then we are free to begin our own tag with alert in it. So we have successfully managed to pop up an alert, and that proves that this is also vulnerable to XSS. And this was a case of DOM-based XSS. So those were the three types of XSS that we saw, and now let's move on to methods to prevent cross-site scripting. There are a good number of ways to do this, but then the best two methods would be to obviously to validate your input and to encode your output. So by validation, what I mean is to, ensure that it conforms to expected formats. So as soon as you encounter certain, banned characters like script, like angle brackets or quotes, then you would not let that input get passed into the web application. And then that is what validation means. And sanitization is also essentially the same thing. You're essentially ensuring that the input is sanitized and it is free of certain characters that would cause problems. You may use libraries like use libraries like DOM Purify, which essentially let you sanitize HTML and remove malicious, JavaScript in it. It essentially only gives you the clean bit of HTML that you would require and would remove any unwanted bit of JavaScript in it. And then, yeah, the other way would be to encode your output. Typically, you would require a combination of all of these, but then, yeah, I'm just pointing out the individual ways to do that. And then output encoding means to escape characters like these using certain libraries of JavaScript. And then also encoding HTML entities so that, like before, when you like in the previous example, when we were writing image with whatever it came after it into the web page using document or write, if we have proper libraries in place, it would not let you do that. It would, and as soon as it encounters certain, invalid characters, it would not let you write data onto the web page just like that. And then use CSP or content security policy headers. So this would be a header that is part of the request, and you would set its attribute to source. So basically, it has an attribute called script.source, and then you can set it to self. This means that only scripts that are part of the same domain are allowed. It would not allow any, script that has an origin that is different from the server. So that would be a way to prevent XSS, and then use HTTP only flags for cookies. This would ensure that cookies are transmitted only through HTTP, and then it wouldn't let you, use document.cookie to access the cookie that is used for user authentication. So in this case, if you use HTTP only, document.cookie won't work. And then also use secure that to ensure that it's sent only over HTTPS, which is a much more secure protocol, which you guys already know. And then that was all for XSS. Now, uh, hope you guys don't have any doubts before we move on to the next topic, right? So yeah, the next topic right here is cross-site request forgery or CSRF. And before we begin, let's discuss what cookies are, right? So, like we've been talking about cookies all along, but this is exactly what they mean. Cookies are small pieces of data that get stored on the victim's browser with a purpose to remember, it may be to remember login information so that users can be authenticated and for sessions, right? And then it can also be used to remember preferences or to track data across visits. When you visit websites, you may encounter third-party cookies being, you may be asked to whether you want to accept or not third-party cookies. The purpose that this serves is so that third parties may know what kind of websites you've been visiting so that they can offer you personalized ads and stuff like that. And yeah, the most important purpose of cookies is to probably manage sessions and to personalize responses from a particular website. So if a cookie is set to a particular value, then the website might know that, okay, this cookie is corresponding to a particular user. And then that's how the website might know that, okay, this is the user who's visiting the website. And then it also helps the website maintain states that are specific to the user. Like if it's a bank, you know, website, for example. I mean, this is very unsecure. Not This is not followed at all currently, but like cookies could probably be used to maintain the current balance or whatever, right? So that's what is meant by states. Now, what is CSRF? It is essentially a vulnerability that, you know, allows an attacker to trick a victim into performing unintended actions on a website where the victim is already authenticated. So let's say a user is visiting a website which has a login, which has an authentication system and everything. So the user is already authenticated to the website. Imagine this. Now, and what an attacker might aim to do is they could try, you know, forging a request on behalf of the user to the server. So when this request is being sent to the server essentially thinks that, okay, this is the user who's visiting the server and not someone else. So when the server is tricked into believing that it is a legitimate user who's, you know, sending a request like this to a server, then that would be an example of CSRF. And then, yeah, this type of attack typically exploits the trust that a website places on authenticated users. So that's what happens here. A website essentially believes that it is an authenticated, you know, legit user who is visiting a website and sending out requests and not an attacker. So yeah, okay. For CSRF, there are three very important requirements, like XSS, but like in this case, they're different. So first of all, there must be some sort of vulnerable action that is of some interest to the attacker. So this could be, for example, to update a user's email address in a particular website, right? So in case the user has an account in the website and it is maintained with, you know, an email address as part of it. Now the attacker would intend to update the email address to something else so that they can gain access to the account. So this would be the relevant action in this case. Now, the second requirement is that session management is purely based on cookies. So this is crucial for XSRF. There must be no, you know, other anti CSRF measures in place, and sessions must be managed only through cookies. So as long as only cookies are being used to know who's visiting a website, then it would be vulnerable to CSRF. And then the third requirement is that there are no unpredictable parameters of the request. So you know, what this essentially means is that the attacker knows exactly how a request to perform a certain vulnerable action would look like. I mean, it's not just the structure of the request, but then the attacker should also know what exactly are the parameters that are part of the request. So there should be no parameters that are, you know, for instance, cryptographical hashes or something. There must be no random parameters. All parameters of the request must be predictable by the attack. So if these three conditions are satisfied, then a CSRF attack is possible. So let's follow a CSRF attacks example step by step. First of all, we have a website which has a vulnerable feature, right? So now this feature is of interest to the attacker. For example, there is a form on a website that uses the following post request that changes the email of a logged in user. So like I said, there is a user who's already authenticated in a website, and an attacker would like to update the user's email to this. So this is a typical request that any normal user would send to the website in order to update their email. It would be a post request, you know, with the host and the URL to change their email/change, and then the cookie. So, like I said, this request, right? The server uses only the cookie to know that it is this particular user and it in this session who's intending to change their email address. So only cookies are being used to authenticate user or know about the session. And then also this is the updated email. So what by this it is clear that, you know, all parameters of the request can be predicted by the attacker. Only thing is cookie, and that is, we'll come to that later, how when an actual CSRF attack is carried out, how the cookie is also added to the request. Now, here there are no unpredictable parameters, right? There are no hashes or anything. Every parameter is in plain text, and all you need to do is include the updated email in the email header, in the email attribute, sorry. So how exactly is this action vulnerable? So the three requirements are satisfied. Only cookies are being used for session authentication, and there are no CSRF tokens. And tokens are an anti-CSRF measure. We'll be coming to that later. So in this request, there are no tokens that are part of the request. And like I said, all parameters are predictable. That is, the attacker knows the exact request fields. Like they would know what exactly to include in the request in order to force a request. So the next step would be the attacker then would craft a malicious request. So this can be done either by hosting a separate server with a malicious HTML page as follows. Now, yeah, what I mean by hosting a separate server with the pages, the attacker would then create their own sort of server with this, bit of HTML in it. It is essentially contains the form which submits which performs this action. And if you look at this action, it would be action equals vulnerablewebsite.com/email.change. Keep in mind, this is the same URL for the email updation that we saw here, vulnerable website and then email/change. So this particular action is to send out a post request to this URL, which leads to an updation of the email. And then this would be a hidden form within the website. So that means anybody who's visiting this attacker controlled website. So the whole thing is present in an attacker controlled website, but then what happens is this particular website is sending this email updation request to the vulnerable website. And then it would be hidden so that nobody would know once they visit it. And then yeah, name equals email, and then value equals attacker@example.com. So this would be the updated email that the attacker would like to put in place of the original email of the authenticated user. And then the form is closed. And like I said, like you can see here, there's a script that begins and ends, and within that script you have document.forms, and then this zero refers to this very first form here, and then you have the submit function. So this bit of JavaScript right here, what it does is it auto submits this form, right? So suppose you were to visit this malicious website, and then that could be through you clicking a link or clicking on a link or something. As soon as you visit this particular web page, then this action gets performed, and this form gets auto submitted, and then whatever action that the attacker would have intended to perform gets executed. So that is how CSRF works. An attacker essentially forges a request that the server thinks actually came from the original legit user, but then it instead came from this particular website that is controlled by the attacker. Now, yeah, once the malicious website has been hosted with the malicious bit of HTML in it, the attacker would then lure the victim into visiting this malicious page. Once that happens, okay, yeah, this could be done through, by sending the link through email or social media or embedding the link in blog posts or something. There are many ways to do this. This is okay. This is not part of the CSRF attack, but then this is a separate topic in itself. This would come under phishing or maybe social engineering or whatever. So yeah, the attacker would then induce victims to click on that particular link, which would lead to this HTML page, and then this action gets performed, and then the malicious request gets submitted to the server, all without the victim's knowledge. So that is how CSRF works. Yeah, so once the victim clicks on the link and on visiting the page, the form gets auto submitted and the request to update the email address is sent to the server on behalf of the victim, but the victim would have not even realized it. So now, how does this actually work? Like, okay, an attacker has sent a request from a website from a server that is controlled by the attacker, right? But then like I said, it needed a cookie. The server needed a cookie to know that it is this particular user session this particular user who's intending to change their email. So that is through cookies. So once, okay, let's say that that the legit user has already logged in to the vulnerable website in a particular browser, and then he or she clicks on this malicious link in the same browser, and then the cookie is also saved, by the way. If that's the case, then what happens is the browser automatically attaches the cookies from the session that is ongoing to this forced request. So this post request would also have the same cookie that was originally part of the, legit request, and then it just gets appended on into this malicious request instead. So now the same cookie of the authenticated user is used here. Once this request reaches the server sees the session cookie, and then the server's like, okay, so this particular user is intending to update their email address. The cookie and everything is there. Everything looks good. So what the server does is the action just gets executed and the email address gets updated. So yeah, the server would then process this request as if it were initiated by the logged in user. And now the attacker would have complete control over the website and of the user's account. So all of this happened without the user even knowing what was going on. All they did was they clicked on a random link that was sent through phishing or whatever, and then they unknowingly visited this page, and then this action got executed. And then now they don't even have access to their account anymore. So, is everything clear until now? Like, do you guys have any doubts as to how CSRF is working before we move on to the demos? I mean, the demos would probably clear up things a lot better, but does anyone have any doubts right now? Okay, I'm assuming that's a no, I guess. And then let's okay, now if at all GET request, so in the previous example, we saw that a post request was being initiated in order to perform this particular action, right? The action of updating an email. Now, in the rare and unlikely case in which a GET request is used to perform a state changing action, which is like through this particular URL, right? Imagine this URL has an endpoint called delete user, and then this user ID helps identify which user's account is to be deleted. So now when somebody uses this URL, they would essentially be submitting a GET request to the server and this particular endpoint in order to delete this particular account. So now, what an attacker could intend to do is they could initiate a force request, obviously, to this particular endpoint. Now, that would be through a GET request. Now, all they need to do is the, you know, they just need somebody to initiate this request. Now, that can be done by setting the source of an image in any website to this particular you know URL, so that now this image can be embedded in any website. That can be through XSS, like we saw earlier. If somebody is able to insert a script tag into a website, then they would also be able to insert an image into any website. And then if they set the source equal to this particular URL, then a request would be sent from the victim's browser to this particular URL, and then whatever action that the attacker intends to perform will get performed. And now it's time for the demo of CSRF, and I hope nobody has any doubts. Okay, let's take a look at the demo then. Now for this demo, we'll be using Burp Suite in order to intercept the request. So it's time for you guys to open Burp Suite, and first of all, let me send you the link to the demo. You may take this gap to sign into your Portspeaker accounts and open Burp Suite. So once again, we'll be doing the easiest dem lab in this series. I'll also be sending the link in WhatsApp. Hope all of you would have Burp Suite up and running by now. You may either use the inbuilt browser or you can config if you already have Firefox configured to the Burp Suite proxy, you can do that. But they both work. Uh, I've also sent the link in WhatsApp, so you guys can maybe use that as well. I'll give you guys some time to try it out yourselves before I do it myself. In case you have any doubts, please don't hesitate to ask them in chat or later on if that's fine with you. Okay, now I'll be doing the demo here, so you can follow along if you would like. So this looks like a blog post, and let's first look at the lab description before we actually do it. This lab's email change functionality is vulnerable to CSRF. To solve the lab, craft some HTML that uses a CSRF attack to change the viewer's email address and upload it to your exploit server. So yes, typically in labs like these, they have like I said in the description, you needed to force a victim to click on the link, right? Instead of that, here we are simulating that action by sending the HTML to this what is called this exploit server, and what that does is it essentially simulates an attacker luring a victim into visiting their HTML. So that's what they mean by uploading it to your exploit server, in case somebody didn't find this clear. Anyways, let's get started. So we have this blog, and then let's look at my account right now. let's see what's going on. So it's asking us to log in with these credentials, right? So let's first do that. Okay, now we've logged in and this is our email address. Now let's maybe try to update, our email to something else. Now, before we submit, let's try to intercept this request in Burp Suite to see what's going on, right? So I've Burp Suite open and then I've turned on intercept. Let's click on update email. Now here we have the post request and okay, so let's take a close look at this request. It has the cookie like I explained like I explained a few minutes back. It's using only a cookie to authenticate users, right? So only the cookie tells the server that okay, it's this user who would like to update their email, and we also have the updated email down below. So it's URL encoded, and yeah, this is what a typical request would look like. Now, from an attacker's perspective, what we would like to do is we would need to change the viewer's email address and to something else, right? In order to do that, we should try to host our own HTML, which performs the above action and updates a user's email. So let's go back and then. So in the explanation, I had a bit of HTML. I also have a similar bit of HTML that I saved over here. Let's first take a look at that. So this bit of HTML right here is what we need in this example. So I'll give you guys a run through of what this is about. So like in the previous example, this also has a post request with an action that is submitting a request to this particular URL, which is essentially the exploit server, same thing that same, you know, and then it's also hidden so that anyone, within the exploit server, anybody who visits this particular HTML page would not see it. And then you're changing the value to the updated email. So let's change anything to something else. And also we need to replace your lab ID with the current lab ID with which we are accessing the lab so that the exploit works in this particular lab. So I hope you guys are able to follow along, and I'm sure most of you would have been able to solve this already. Let's do this anyway. So now, let's go to the exploit server now, and then let's submit the request. the HTML page that we just, let me turn intercept off before that. So now we're in the exploit server. Now this is where we deliver this is the header, but let's put the request in this instead. So we've copied the HTML that is required, and let's change our this bit of your lab ID into the actual lab ID. And then now let's store this in the server. Okay, now it has been stored. Now, if we try viewing it, let's see what comes up. Now, here there's nothing that happens. Now let's just, oh wait, I didn't. Yeah, let's now turn intercept on and then view exploit to see what the updated request looks like. So now instead of the original, you know, email, right, we have this updated request that is part of the let's now try sending it and then sending it to repeater and see what the response looks like so that we know. Let's now deliver the exploit to the victim. Oh, we have intercept on. So it's taking a while to load. Let's see what happens. Okay, it's taking forever. I don't know why that's happening. I hope most of you have been able to solve the lab now. Does anyone of you have any doubts from this topic? If no, then let's move on. Okay, preventing CSRF. We have a few methods to prevent CSRF attacks. And then, like I said previously, the most important one among them is to use tokens, CSRF tokens. Now, tokens are unique and random strings that are, generated for each session or request. They are usually cryptographically secure hashes, and they're randomly generated. And in an ideal use case, they would be, tied to a user and they're specific to the session also. So you can't use the same session, token across different sessions for a particular user. And it's also the same for every user so that no attacker can predict them, in order to propagate a CSRF attack. So, and yeah, they're included in forms or requests as hidden fields or, as a part of the request as a header. And yeah, once they reach the server, they're always validated to ensure that the request is legitimate. So if CSRF tokens are in place, then we know that we have a secure way of, submitting requests that induce trigger state changing actions like we saw before. So when CSRF tokens are part of the request, then attackers won't be able to, exactly force the request like we saw previously, right? And bad usage of tokens must be avoided, in which case CSR field token field must obviously be mandatory. It mustn't be an optional field, and they must be cryptographically secure hashes so that they can't be predicted, and they must be user specific and unique to the request and to the session. That is, they must change depending on the session. They shouldn't be the same for every session, so that no attacker can predict them. And does any one of you have any doubts before we move on to the next topic for today? All right. We have, yeah, okay. Another method to prevent CSRF is to use same site cookies, sorry. And the same site attribute is set for cookies and request headers in order to restrict their inclusion in cross-site requests. So you can set this attribute to one of three values. Like an attribute as in they're part of the request. When you take a look at the request, you will see whether or not it has the same site attribute set for cookies. Like you have the cookie and then it'll be equal to something and then followed by a semicolon and then there'll be same site equal to strict or lax or none. So that is what's meant by same site attribute. And in case the same site attribute is set to strict, then in that case, cookies are sent only with the requests that are originating from the same site as the ones that send the cookie. So in this case, only the cookies that originate from that very site are allowed to be sent and received along with requests. No other cookies will be entertained. So, uh, yeah, so this is probably the strongest and most, strictest form of security that you would like to use. And this is commonly used in, applications that require the highest level of security, such as banking transactions and healthcare applications and stuff like that. And in case it is set to lax, then cookies are sent with same site as well as certain safe cross-site requests. So cross-site requests as in there it is originating from an external source. So in certain requests like get and head, as long as they don't perform any state changing actions, usage of cookies are also allowed in cross-site requests when the same site attribute is set to lax. And the third option is same site being set to none, in which there is no protection at all. Cookies can be sent along with all requests regardless of origin. And this is what is used for third-party cookies, right? Like I described earlier. When you visit some website and there's an ad, server that is, tracking your browser history through cookies, then those cookies would have same site set to none. And if I remember correctly, I think by default, same site would be set to lax, unless you specifically set it to either strict lax or none. So yeah. And if you don't have any doubts, I'm moving on to the next topic for today's session, which is server-side request forgery. Uh, Server-side request forgery is a type of vulnerability which allows an attacker to cause an application to make requests to an unintended location. Now, like in CSRF and XSRF, XSS, you're triggering, malicious execution of JavaScript, and in CSRF, you're triggering an uninitiated request from the attacker's end. But here, what's going on is it is the server itself which is sending out the request, and it is not someone else. So what goes on in SSRF is an attacker would manipulate a user input that the server uses to make outgoing HTTP requests. So suppose there is a server, right, which is, you know, sending out a request to some external, it could either be an external location or it can even be an internal location that is typically accessible only to the attacker. Like the attacker can't themselves visit the resource that the server is sending a request to. If this is the case, then a request may be sent only from the server side and no request and if an attacker sends a request to these locations, then nothing of interest would be received. So in a typical SSRF attack, the attacker might cause the server to make a connection to internal only services within the organization's infrastructure. Basically, the attacker is forcing the server to initiate unintended requests to locations that are controlled by the attacker instead of the originally intended locations that the server was originally sending out requests to. And in other cases, they may
Uh,
be able to, yeah,
yeah. Like, could you explain the base of the SSRF once again, the start part of it?
yeah, sure. Okay. So consider a server, right? When you visit a server and then there is an option to like let's say the server is submitting a request to an external location. That is you're submitting a request to a server, and then the server is asking, okay, I'll use these examples. So let's say Anvesh is the user who's visiting the server who's hosted by Thiru Kailash, right? And then in a typical a normal use case, Thiru Kailash would submit a request to Vibhu in order to fetch a resource, let's imagine, right? Now, Anvesh by himself cannot send a request to Vibhu and obtain any meaningful, useful information. Only the server is allowed to send requests to Vibhu, right? But then Anvesh knows that whenever he sends a request to Tirukailash, uh, the the where the URL like Anvesh knows the location of Vibhu's server, but him by himself he cannot send a request to Vibhu which is of any use to him. Now, what Anvesh could do in order to access some form of data that is stored in any kind of interesting data that is stored in Vibhu's server is by forcing the server to initiate a request to, oh, actually, no. Like in a normal use case, Tirukala's server is sending a request to Vibhu's server. Now, let's say Sriram is a separate server. Now, Anvesh would like to access some kind of data that is stored in Sriram's server, right? Are you able to follow right now?
Yeah, a
Yeah,
bit.
so now Anvesh can maybe force Tirukala's servers to send a request to Sriram's server instead of Vibhu's server in order to obtain relevant information that is sensitive and, you know, useful to the attacker. I'll discuss an example in a bit, so that might probably clear this up much better. It's hard to
So,
describe with,
like, is it
yeah, yeah.
trying to make the intermediate server reach to another server, or are you
Yeah, that's
manipulating something?
yeah, another location. I mean, it need not be a different server by itself. Like, I'll discuss an example right now, and hopefully this will clear you.
Sure.
Clear
Okay.
the,
Okay. Yeah.
yeah, if that's, yeah. So, let's look at this example, right? Imagine a shopping application that uses a backend API to view whether an item is in stock. So, like I said, this is the server that all users will be visiting, right? That is the shopping application, application.com, right? And then what happens is the application, like whenever you visit the server and check for a product stock, this application sends a request to this backend API, which is located at stock.weliketoshop.net, right? Now, that what this means that when any user visits this server, the server then submits a separate request to this API endpoint. Now, suppose the same application has an administrative interface at admin URL of the same server. Now, this is what's interesting to the attacker. Is this now clear, Harsha? Now,
Where is this admin URL being present for the
admin is
second
within
one?
the same server. So, like I said, the target server need not be a separate target location need not be a separate server. It can either be within the same server or it can also be a separate server. What is of relevance here is that the attacker would like to send a request to admin instead of this particular location.
Okay. Does
So
he want to send it to that URL/admin or something?
exactly, that's what the attacker would like to do. Now,
Okay.
like I just said previously, the attacker by himself cannot send a request to slash admin and access any sort of administrative interface by himself. He would have to initiate it through the server, right? Because only the server is in this case authenticated to access this slash admin URL. Does this make sense?
Yeah.
right? So now, typically, what an attacker would do is like, okay, yeah, that's what happens. If the request to the admin URL comes from the local machine, which is the server itself, the normal access controls are bypassed and full access to the admin page is granted. Now, like I said previously, it is fetching data from the stock API, right? And it is returning it to the user who's visiting the server. Now, instead of stock API, if you put slash admin here, whatever instead of the stock API, the server would then send a request to slash admin, and then whatever data that's present in slash admin would be returned to the user, or in this case, the attacker. So then the attacker could just modify the stock API's, original URL to localhost slash admin or 127.0.0.1 slash admin. Now, what is localhost in 127.0.0.1? So localhost and this particular IP address is typically used to loop back to the same server. You would always use localhost and 127 to, access something that's hosted in the same server as you're on. So in the previous, in case of XSS, I demonstrated a server an application that was hosted on the same machine as mine, right? And if you observe the URL, what I used was 127.0.0 slash dot one, and then that would essentially enable me to access any server that is being any server that's being hosted in the same machine as I am on. So in this case, admin is also located in the same server. So then what the attacker would do is he would change the original stock API's URL to this updated URL. So now the attacker is essentially causing the application to make a request back to the same server's admin URL via the loopback network interface. So you get what I'm saying here, right, Harsha?
So you're trying to access the server's admin page, is that right?
Exactly, that's what's going on here. So which is this admin page is not accessible by to the attacker or anyone else who is not authenticated, right? It is only accessible if the server themselves send a request to it or if the actual admin is visiting the server, right? Now, does this make sense?
Okay, yeah, yeah, it makes sense.
Yeah, yeah. So this was the case in which the admin in which the target location was within the same server as the application. Now we'll look at the case in which the target is on a different server which is not accessible to the attacker. In the previous case, it was the target location was within the same server, which could have been accessed through localhost. But in this case, it is accessible through, it is located within a separate server, but it is not accessible to the attacker since it is located in this private IP address. Typically, we would use 192.168 and .x for, private IP addresses, which are accessible only within a private network. And even in this case, the server is also part of the private network, right? So since the server is allowed to access this particular URL through the private network, that is fine, but no one else can access it because it is located in the private network. In that case, the attacker would then update the stock API's URL to this particular URL. And also here, let's say this particular location contains some sort of sensitive information that is of relevance to the attacker. Now, in this case, like I said, the attacker would have to modify the stock API's uh, this thing to this particular URL. Now, one way to detect SSRF vulnerabilities is to manually test out different, you know, URLs like follows, like as follows. So this is the actual server, and then it's fetching this particular uh, about.php page in through this URL, right? And this would be a GET request. Now, let's say we're able to modify this about.php part into something else. In that case, we would be able to access whatever target location that we're otherwise unable to access, right? And then we could try out different example payloads like localhost or 127.0.0.1, or in case all passwords of users are stored in a particular file in /etc/password, then we would maybe set update page to this particular URL. And then we have a demo for SSRF as well. I'll Do you guys have any doubts? Anyone else? Or hope you guys don't have any doubts right now. Before we move on to the demo, right? Okay, let's do the demo then. Uh, oh, wait, sorry. Oh wait, we already have it here. Let's. Uh, right. So we have two examples here. SSRF against the local server as well as against another backend system. It's essentially the same thing, but you know, here we're sending out a request. I mean, essentially forging a request back to the same server. But in this case, we're forcing the server to send that request to another external location. So let's look at this demo first. Oh, I'll also be sending the link in WhatsApp. So just a second. Yeah, I've sent it in WhatsApp. Sorry for the delay. Right. So in this particular lab, it was essentially the same example that I discussed, right? We have an admin interface located in localhost/admin, and then also this server uses a stock check feature which fetches data from an internal system, which is located at stock API. And then what we're essentially supposed to do in order to solve the lab is to delete this particular user, right? So let's get started. I'll wait for a few minutes before. Yeah, we have 10 minutes remaining, so we're almost done with the session. And yeah, if you have any doubts, please don't hesitate to ask. Uh, I'm sorry I used you guys' names to, try to explain SSRF. Like, hope you guys didn't mind me doing that. But yeah. Right, so this looks like a shopping application with products, and let's we have an option to check stock for any product, right? So, oh, actually, I let me open this in the Burp browser before. Right, so let's turn intercept on and then let's see what the check stock request is looking like. And we have our post request here, and like before, it's using this particular URL to fetch this actual stock of the product from this, location, right? Now, what we would intend to do is we need to access the slash admin location that is stored in the server. We essentially need to update this to that, right? So, wait, let me check if you are, yeah. So URL encoding is enabled as I type. So I can just type out slash slash local host slash admin. And then, yeah, that's all I need to do. And then if I do that, I can, let me see if I can access the admin uh, page. So let me forward that request. And yeah, we have successfully accessed the admin page of this server. So we have access to delete each and every user, right? So we are supposed to delete Carlos. So I can't, see if I click on this button right here, what would happen is it would be my own server which is sending out a request, right? I can't do it myself, but then I can only force the server to do it. So if I click on this button right now, nothing will happen because I am not the admin, right? But then if I do it, if I instead change the original request to add a delete, update it to the actual deleting endpoint, then I could maybe execute the target action. So let's first copy the URL that is necessary to carry out this particular action. And then let's try using it in the uh, actual request. So let's try the whole thing again. But instead of just admin, we'll have slash admin and then delete Carlos. We'll essentially do that. So let's check our stock again. And then let's modify the API endpoint. Now here, oh wait, yeah, instead of this, we need localhost. So yeah, we just need the bit at the end. The rest is same as before. HTTP, yeah, uh, HTTP and then localhost slash admin slash and then delete
Could you
use.
explain the start part of your URL?
Oh, this. Are you talking about
Yeah.
this? Oh, this is nothing but the URL encoding of the, colon. Typically, URLs like these are encoded, right? So that's why, see, had I not enabled URL encode as you type, if I typed, you know, a colon manually, it would appear as it is. But then I had enabled URL encoding so that it actually visits the correct URL. So now if I type in a colon, this is what appears. Is that clear?
Oh, okay, okay, yeah, yeah.
Yeah. That's all that's going on over there. And yeah, we have the correct URL, delete username equals Carlos. And then let's forward it. And then, yeah, let's turn intercept off before. Yeah, that's it. We have solved the lab. And let's again take a look at the, uh, users list and see if Carlos is part of them. I mean, we don't really need to do that because we know that we solved it anyways, but yeah, let's check stock, inspect the push request, and then HTTP local host slash admin forward. There we go. We don't have Carlos anymore, so we've successfully deleted uh, Carlos from it. And yeah, and the next example, okay, the problem with the next example is we don't exactly know which location. We just know that it's in a private network, but we don't know the full IP address. So the problem with the next lab is we need to use burp intruder to, brute force through different values of IP addresses. That is only from 1 to 255 because I'll show you guys the actual lab and then you guys will. I'll basically explain what the next lab is all about, but then we wouldn't be able to completely finish doing the lab in this session because the whole point is intruder requires a lot of time and community version to finish, trying out every single option. So in this particular lab, what we're supposed to do is instead of localhost slash admin, we're supposed to access the server that is located at this address, but then we don't know what X is. It can be anything from 1 to 255. So testing out 255 different values and then uh, that would take a long time in burp intruder, especially in community version because it is throttled. And but then you guys essentially know what you need to do in order to completely solve this lab, right? So I won't be doing it right here. So yeah, all you need to do is instead of localhost slash admin, like before, we need to update it to this, and then we set the we essentially are supposed to fuzz through different values for this X character, and that is possible through burp intruder. And yeah, that's all for the demos for today, and let's move on. We don't have much left. So yeah, preventing SSRF attacks. There are three major ways to do that, and you can validate and sanitize all user inputs. You may block inputs containing host names like localhost 127 and 192.168 so that you can't, force servers to send an intended request to these locations. And then this would fall under the criteria of blacklisting, but then typically it would be much better to adopt a whitelisting based approach, which is much more secure and you have very few options that actually, are valid. In case of blacklisting, anything that, you know, you can use, there are many options that you can adopt to circumvent these blacklisting measures. For instance, you can also use instead of 127.0, let's say these are the only addresses that are blacklisted, right? Instead of 127, you could use something like 0177, which essentially resolves to the same 127.0.01 localhost address. So there are ways to circumvent blacklisting methods, but in case a whitelisting method is adopted, then it would be much harder to circumvent, you know, a measure like that. And then limit internal access, restrict the server's ability to access internal services like admin panel without authorization. So in this case, you would limit even the server from accessing, certain sensitive resources without proper authorization. So even the server's requests would have to contain authorization tokens that tell the server that, okay, this is a legit request that is from the server and not, randomly initiated by an attacker. And then and then error handling. Do not expose detailed error messages that could, that could maybe give clues to attackers that the server is sending out requests to this particular API. So then if certain error messages are, exposing certain details like these, then the attacker can get a better idea of what the request looks like. As in, the attacker would, know that the server is sending out requests to this particular URL, and then know exactly what to modify and what not to modify. If, certain error messages and traceback statements are also part of the server. And yeah, those are the main measures to prevent SSRF attacks. So yeah, that's all for today's session, and hope you guys, liked it. And in case you have any feedback or in case you have any doubts, please don't hesitate to ask. You may DM me later on, and then you please don't forget to fill the feedback form so that we know what to improve upon and all that. And yeah, thanks everyone.